Okay, let's solve the third example. A body of weight 50 Newton is suspended by inextensible string. The body is pulled aside by a horizontal force P Newton until the string makes an angle of 47 degrees with the downward vertical. Find Roman figure 1, the force P Newton. Roman figure 2, the tension in the string. So the first thing we are going to do is to sketch the diagram, and this is the diagram according to the question. This is the body and this is the weight of the body. This is the string that's acting upward. The tension of the string is acting upward, and this is the weight of the body. The question says the body is pulled aside by horizontal force P until the string makes an angle of 47 degrees with the downward vertical. So we need to draw that. Let's redraw the diagram. We still have the wall, and let's represent the body by a point, and this will still represent the weight of the body, which is 50 Newton. 50 Newton. This is the horizontal force that is applied to pull the string. So if this horizontal force is pulling the body, it means the string is going to move towards the horizontal force P, and therefore making an angle of 47 degrees with the horizontal. So this is how the diagram will be. And here we have the tension, we have the horizontal force, and we have the 50 Newton. So this is the first diagram. We can try to trace this one down and extend this one to make this angle to be 90. Then the angle here is going to be 43 degrees. So to find the value of P and T, we need to resolve all the three forces acting on the body. We need to resolve them both in horizontal component and vertical component. And from our previous lesson, we discovered that horizontal component is given as F cos theta, and vertical component is given as F sine theta. Since we have the body in equilibrium and we have three forces acting on this particular body, that is force P and force 50 Newton and force T. So let's resolve the first force, that is force P, with horizontal component is going to give us P cos 0, because the value of the angle here is along the x-axis, which is 0, and this is going to give us P. If we resolve the force of 50 Newton in horizontal component, we are going to have, that is 50 cos 90, and this is going to give us a 0. Likewise, let's resolve the force in the string, that is T, along the x-axis, that is the horizontal component. That is going to give us negative, because it's on the negative x-axis, negative T cos 43, and that one will give us negative 0.6820 T. So that is that. For the vertical component of P, here we are going to have P sine 0, and P sine 0 is going to give us 0. Likewise, P, that is 50 sine 90. 50 sine 90 is going to give us 50. But let's pay attention to this force is along the negative y-axis, so this one will give us negative 50. And the third one is resolving the tension T along the vertical. The tension T along the vertical is going to give us T, that is T sine 43, which is going to give us 0 0.6820T. So with this now, we have resolved all the three forces into both horizontal component and vertical component. So since the body is at equilibrium according to the condition of equilibrium, that the summation of vertical component equal to 0 and the summation of horizontal component equal to 0. We'll be making use of this one. Therefore, I can say is 0 equal to the summation of all the horizontal component, that is P minus 0.6820T. This one will give us equation 1. Also, we can say is 0 equal to, for all the vertical forces, we can say 0.6820T minus 50. This one will give us equation 2. So we are going to use these two equations to find the value of P and T. So I can say in equation 2, that 0.6820T equal to 50. Making T the subject of formula, we have T equal to 50 all over 0.6820, and that is going to give us 73.31 Newton. That is the tension in the string. To find P, we can make use of equation 1 or equation 2. In equation 1, we have P minus 0.6820T equal to 0. Then I can say P equal to 0.6820 multiplied by the value of T, which is 73.31. And that one is going to give us 53.62 newtons. And this is the horizontal force. That is the horizontal force used to pull the body along the horizontal. So this is the value of P, and this one gives us the value of T, which is the tension in the string. And that is the whole question. If you have any question, you can ask. Don't forget to study the example 1, 2, and 3. Then after this, if you have any question, you can ask me. Yes, God bless you. That is how to use resolution of forces to solve three forces in equilibrium. God bless you. Thank you.